Hi everyone! In this video we will be talking about exploiting SQL injection using DEM vulnerable web application. SQL injection is one of the most widespread and dangerous vulnerabilities. Its main goal is to execute an arbitrary query to the database. The request can be anything: to read, write, modify, and delete any records. But it's not limited to these threads. It all depends on the attacker, the system used, and on its configurations. 5 main consequences of SQL injection are gaining access to unauthorized data, reading system files, gaining administrative privileges, remote code execution, and unauthorized data manipulation. There are different types of SQL injection. For example, union query, error-based, stacked queries, Boolean-based blind SQL injection. To perform a SQL injection attack, an attacker must first find vulnerable user inputs within a web page or web application. For example, the user can be asked to provide the user ID, and instead of it, the user will give wrong input value in order to modify a SQL statement that you will unknowingly run on your database. If a SQL expression was successful, the attacker can change the logic of the SQL query execution as needed. Most often, an attacker would want to retrieve tables with the most sensitive user information.
SQL injection attack initiates when the attacker injects a malicious SQL query in a web form. The query then proceeds towards the firewall where authorization takes place. Once the query is successfully authorized, it is then sent to the web server and application server for further evaluation. This is where authentication happens. Once the query passes all these processes, the query is then executed in the database and the desired results are retrieved.
The first step in our attack is to understand what is being queried. We can see from this PHP file our input, or ID, is being entered into the following query. Select first name, last name from users where user ID equals ID. ID being whatever we're inputting into our query here. We also have to take note that our query expects 2 things to be returned, the first name and the last name. So let's see if we can figure out the first and last name from the user 1. Alright, great. So we have the ID we entered, or the query we entered, as well as admin, which are the first and last name of that user. So now how would we go about making this query work for all of our users? So we'd actually use some SQL injection. So we're going to edit this SQL to actually match what we want. So how would we do that? We're going to make our query think that it ends this ID early and continue it on afterwards, and then comment this out later. So that the way we do this is simply saying select first and last name from users where the user ID is equal to 1 like we had before, or 1 equals 1. And the reason that works is because it's not just going to select the first and last name from the users where the ID is 1, but it's going to always select it because 1 equals 1 is always true. So it's going to select all of the users' first and last names. So let's go ahead and enter that and see if that works. Awesome. So as we can see, we get the first and last names of all the users. The next step we're going to take is to find out what tables exist in the database that could contain sensitive information, such as the username and password. Thankfully, each SQL database has metadata stored in an information schema that stores stuff, such as table names and column names, which can help us identify what's stored in each table. When we do this, we have to keep in mind our PHP file expects 2 outputs from the query to display. So what we're going to do is we're going to use the SQL command union to join together 2 selects. So we're going to select null, so that means we're going to have our first name be empty for all of them, and we're going to select our table name from our information schema, which is the metadata, and it will hold all our tables. So we're going to say, hey, do it for all the users and take all the table names. So let's go ahead and do that. Awesome. Here we can see all the usernames, or all the table names. So let's go ahead and find a table that looks like it makes sense. Users. Hey, that could hold some information on users. In fact, we already saw that in our PHP file, and we know it held the first and last name. So what we're going to do is now, instead of using it for table name, we're going to edit our SQL to not just deal with table names, but to deal with column names. So we're going to use basically the same command as before. We're going to take 1 or 1 equals 1, union select null. And now we're going to take the column name from our information schema, make sure that we're using the metadata for columns. However, this would list all the columns for all the tables. We don't want that. We only want the columns where our table name is users. So let's go ahead and add that. Alright, great. So we can see a few things here. We can see user ID, first name, last name, user, and password. Hey, user and password seems like username and password name. So let's go back to our SQL and realize now that what we want to do is say we want two things. We want to select our user and our password from our user's number. So let's go ahead and do that. And there we have it. We have our users and their passwords hashed.
SQL injections can be tracked using the intrusion detection systems, also known as IDS. IDSs track the injections by creating a report of the events which have already taken place in the past. DAM vulnerability web application uses PHP IDS as the web application is coded in PHP. When the attack is unsuccessful, the web application displays the message on the left and the user is temporarily blocked from inserting more queries. However, when a successful attack happens, the description of the session is logged in the PHP IDS log file, which can be later used by the security department to apply security measures.
First of all, what the user can do on their end is to make sure their password is complex, which inevitably would make its encryption more complicated, so that if a site is insecure, password attacks such as dictionary and brute force will be far less successful. On the developer side, there is much that can be done in the backend to prevent SQL injection. Looking at the application, the system expects to receive a numerical value as input. We need to make sure this is exactly what it gets, nothing more. To do this, we must wrap most of the functionality that interacts with the database in an if statement. This if statement simply checks whether or not the passed-in value is numerical by using the PHP function isNumeric. There are many similar functions for different languages. With this if statement, there is no way anything but a numerical value is getting past this. This small change solves our immediate problem, but let's not stop there. We can also make a small tweak to the SQL query itself. By adding the limit clause, we will have the database retrieve only one record per query. This eliminates the earlier issue, being able to retrieve multiple rows in multiple tables through SQL injection. Alternatively, before outputting the results of the query, you can wrap that around an if statement that manually checks how many rows have returned. In this case, it must be 1. Through testing, we were able to confirm that the system now ignores any input that isn't a numerical value and only returns one row anytime the form is submitted. As we touched briefly before, a local password policy is something that should be considered. Users should be encouraged, if not enforced, to create passwords that contain a mix of letters, numbers, and symbols. A hashed password of this caliber would be hard to decode. The access control policy should also be implemented. For example, if users had roles, only users with the role of administrator would have been able to search the database for users based on an ID to begin with. With roles or permissions, attackers have less of an opportunity to attack.